In this video, we'll talk about polar coordinates and their relationship to rectangular coordinates. We'll define polar coordinates, how to plot polar coordinates on the polar coordinate plane. We'll talk about the relationship to rectangular coordinates and how to convert between polar and rectangular coordinates. So first, I thought it might be useful to contextualize polar coordinates by thinking about rectangular coordinates. So with rectangular coordinates, we have an ordered pair with an x and a y. Typically, we start at the origin, walk over x units, and then go up y units to get to our xy coordinate pair. In polar coordinates, the polar coordinate system uses distances and direction to specify the location of a coordinate in the plane, as opposed to two positions relative to the axis. So we choose an origin and draw out from that the polar axis. You'll often see the polar coordinate plane with both a vertical axis and a horizontal axis. Then when we write the coordinate pair in polar, we'll use r and theta, where r is the distance from the origin to the point, P, and theta is the angle between the polar axis and the segment OP. So if we had this point, P, that's what r theta defines. R is this distance, and theta is the angle there. Typically, you'll go angle first and then r. As we were with the unit circle, positive theta will indicate counterclockwise, negative theta will indicate clockwise. R, if it's positive, we draw the length r out to find the point P. And if r is negative, we need to do something a little bit different. We'll trace out the angle theta and then go the distance r in the opposite direction. So if r less than 0, we'll kind of trace out like this. We'll trace out the angle theta and then go the length r this way. And this will be our point P. So kind of similar intuition for negative and positive for r. A little different for theta, but since we've been getting used to thinking about trigonometry in the unit circle, it should feel relatively intuitive. So theta first, and then r. The definition of the polar coordinates. In the polar coordinate system, we use distance and direction to specify the location of a point in the plane. A point P can be assigned a coordinate pair, r theta. R is the distance from the origin to P. And if r is less than 0, then the point r theta is the point absolute value of r units from the pole in the direction opposite of theta. Theta is the angle between the polar axis and the segment OP. If theta is greater than 0, we go counterclockwise. If it's less than 0, we go clockwise. And I've drawn a couple images here. So on the left one, we have a positive theta and a positive r. On the right one, we have a positive theta and the length r, but then we have to go in the opposite direction, absolute value of r units, to find the actual point P for r theta with r less than 0. So now let's see how we graph a given point. So first let's plot 3, 3 pi. So first we need to find that angle. So let me draw, this is the origin and this is the polar axis. I'll do this first one in green. So we need to go 3 pi radians around the unit circle, which will take us, that's 2 pi, and then 3 pi lands us there. And now we need a length 3 units, so we could call that maybe 3 units like that. And the point at the end there, P, is 3 pi. So similarly again, for negative 4 pi over 4, we'll start with the origin and a polar axis. We'll go pi over 4 units in the counterclockwise direction, so that gets us right about there. That's pi over 4, and then we need to go negative 4 for the radius. So since we're going in the direction opposite of theta, we're going to end up over here. That's the point P, negative 4 pi over 4. And lastly, for 5 pi over 4, we again start with the origin and a polar axis. Do this one in purple. So we need to go 5 pi over 4 units around, so that lands us here in the 3rd quadrant, and then 4 units out. 5 pi over 4. So it's interesting to note with these last two, they actually have the same point. They land in the same spot, right? Which is the interesting thing about polar coordinates. And this should make you think about our sines and cosines and everything. We can define the same point a number of different ways, just like we could have the same output for sine and cosine for a number of different angles. So now, to help us understand the relationship between rectangular coordinates and polar coordinates, let's try to derive some equations to help us get from one to another. So if we have our point xy there, which is in rectangular coordinates, and we want to write that in terms of r and theta. So we want x in terms of r and theta and y in terms of r and theta. Well, that just makes me think of sines and cosines, right? If we take, for example, if we take sine of theta, that would give us y over r, which would imply that y equals r sine theta. And similarly, since cosine theta equals x over r, x equals r cosine theta. So if we're in polar, we can convert to rectangular by multiplying r and the cosine of the angle to get x, and r and the sine of an angle to get y. So this is polar to rectangular. But if we want to go the other direction, we have to find a slightly different formula. We want to find the radius in terms of x and y. That makes me think, when I see this triangle, that makes me think of the Pythagorean theorem. Specifically, r squared equals x squared plus y squared. So if we have x and y, we can find r by squaring both x and y and adding them to one another. And then finding the angle, we need to think of something that uses both x and y that we can easily find an angle from. So that makes me think of tangent. Tangent theta equals y over x, which would imply that theta equals tan inverse of y over x. Of course, provided that x does not equal 0. So that's how you get from rectangular to polar. So the relationship between polar and rectangular, to go from polar coordinates to rectangular coordinates, we multiply r and the cosine of the angle to get x, and r and the sine of an angle to get y. To go from rectangular to polar, we square both x and y, add them to one another, and that gives us r squared, so of course we would need to take the square root. And then to find theta, we use tangent. Of course, provided that x does not equal 0. So let's find rectangular coordinates for the point with polar coordinates 4, 2 pi over 3. So remember, we need to use x equals r cosine theta and y equals r sine theta. So that would give us 4 cosine 2 pi over 3 and 4 sine 2 pi over 3. Cosine of 2 pi over 3 gives us negative a half, so that's 4 times negative a half, and the sine of 2 pi over 3 gives us root 3 over 2, so that's root 3 over 2, and we have negative 2 for x and 2 root 3 for y. So the equivalent coordinate pair in rectangular coordinates is negative 2 to root 3. In the next video, we'll look at polar equations.